Dear students, welcome to the third class on circles of 10th standard mathematics. I think that you have learned very well the contents that we have discussed in the last two classes. I hope that you remember the terms arc, central angle of an arc, alternate arc, angle made by an arc at its alternate arc, angle in a semicircle, angles in the alternate arcs, and I think that you know the properties related to these terms and the theorems that we have formed in the last two classes. You know how to construct a half degree or a quarter degree angle. For an example, you know how to construct a 23.5 and 11.25 degree angles. Though we are not able directly to measure such an angle using protractor, we know to get constructed such an angle. Today we have to discuss a new topic, a quadrilateral, a special quadrilateral. Its name is cyclic quadrilateral. We will discuss at what time a quadrilateral is called cyclic. What are the properties of a cyclic quadrilateral? Then we will do some problems related to cyclic quadrilateral. Once again, I welcome you all to the third class on circles. A cyclic quadrilateral. If all the vertices of a quadrilateral are on a circle, we call the quadrilateral a cyclic quadrilateral. See the figure. Here, the quadrilateral gets its all vertices on a circle. We call the quadrilateral a cyclic quadrilateral. Hence, let us define a cyclic quadrilateral like this. You can write down this one. If all vertices of a quadrilateral are on a circle, then the quadrilateral is called cyclic quadrilateral. Always to tell a quadrilateral cyclic, it is not needed to show a circle like that as passing through its all vertices. Even though the circle is not seen there, let us tell the quadrilateral a cyclic quadrilateral. And so a cyclic quadrilateral can be told like this also. If we can draw a circle as passing through its all vertices, then we can tell this quadrilateral a cyclic quadrilateral. For all quadrilateral, it is not possible to draw a circle as passing through its all vertices. It is for some special quadrilateral that a circle can be passed or a circle can be drawn as passing through its all vertices. Okay, and so if we name this quadrilateral as A, B, C, D, we see that cyclic quadrilateral get two angles, angle A and angle C. They are angles in the alternate arcs because BAD and BCD are alternate arcs, and angle A and angle C are angles in the alternate arc. Like that, angle B and angle D also are angles in the alternate arcs. We know angles in the alternate arcs are supplementary, mean their sum is 180 degree. And so if we consider any cyclic quadrilateral, its one pair of opposite angles will be angles in the alternate arcs, hence their sum is 180 degree. And so let us write that one. And so here in this figure, angle A plus angle C, they are angles in the alternate arcs, therefore their sum is 180 degree. Like that, angle B plus angle D also is 180 degree. Hence here we get a result. If we consider a cyclic quadrilateral, its opposite angles gives the sum 180 degree, or its opposite angles are supplementary. For any cyclic quadrilateral, its opposite angles are supplementary. And so let us write that one. It is very important result. We have to apply this result when we try to solve problems. Okay, you have to put this one in a box. And so first of all, draw such a figure, then write the heading cyclic quadrilateral and explain these much things there in your notebook. At last this result and put that one in a box. We have learned what is a cyclic quadrilateral and the property with a cyclic quadrilateral, that is opposite angles gives the sum 180 degree. Now let us think about the condition. At what time a quadrilateral will be cyclic? That is, at what time or what is the condition to draw a circle as passing through all vertices of a quadrilateral? If we try to draw a circle through three vertices of a quadrilateral, see here a quadrilateral given. if you try to draw a circle through these three vertices, that we know how to draw a circumcircle of a triangle. With that method, we know how to draw a circle these three vertices. At that time, when we draw such a circle, the fourth point also may fall on that circle. Such a possibility is there. But always the case need not be like that. When we try to draw a circle through three vertices, the fourth point can be outside the circle. Here a quadrilateral is given. If we draw a circle through these three vertices, this point may be out of that circle as shown in the figure. Now one more case is there. At that time, the fourth point can be inside the circle, like this. If we draw a circle through these three vertices, at that time this can be inside the circle, like that. Now come back to the first case. Here we see the sum of the opposite angles gives the sum 180 degree, and so we conclude that is the condition for a quadrilateral to be cyclic. That we will prove by taking these two cases. Now we will find the sum of the angles at these two vertices. By taking the sum of the angle at these two vertices and the sum of angles at these two vertices, we can conclude the condition for a quadrilateral to be cyclic. Okay, we see if opposite angles of a quadrilateral is 180 degree or supplementary, then the quadrilateral will be cyclic. That we will prove by taking the sum of the angles at these two vertices and the sum of the angle at these two vertices. And so let us first take the case, the sum of the angle at these two vertices. See, now the condition for a quadrilateral to be cyclic can be obtained, can be found by answering to this question. See the question. As we said, if we draw a circle through three vertices of a quadrilateral, the fourth can be out of the circle. See, here a quadrilateral is drawn. When we draw a circle through these three vertices, this vertex may be out of this circle. Then, when we draw such a circle, let us name the quadrilateral as A, B, C, D. Now the vertex D is out of the circle. All other vertices A, B, C, D are on the circle. Now let us mark the point where AD meet the circle. Here this point can be named by E like that. Now let us join CE. Okay. Now these activities can be written. Here we have named the point where AD meet the circle by E and CE is joined. Then we have named E where AD meet the circle and CE is joined. Now we see ABCE. ABCE. That one is a cyclic quadrilateral because its all vertices are on that circle. See, ABCE is a cyclic quadrilateral. Okay. Now our aim is to find out the sum of these two angles. Okay, what will be the sum of these two angles? We see angle CEA plus angle B. These two angles together determine opposite angles of a cyclic quadrilateral. Therefore, their sum is 180 degree. That means angle B plus angle AEC, these two angles together will be 180 degree. Now we see, consider triangle DCE. We see angle AEC is an exterior angle. When we consider this angle AEC, it is an exterior angle of these two angles. See these two angles. These two angles are remote interior angles of this exterior angle. We know this angle will be equal to the sum of these two angles. Let us write that step. Angle AEC will be equal to angle D plus angle ECD or DCE, like that. Okay. angle AEC will be equal to sum of these two angles. Okay, now angle AEC equal to sum of these two angles mean this angle AEC will be greater than each one of these two. Okay, these are the components of angle AEC, therefore angle AEC will be greater than these, each one of these two mean, let us take angle D, therefore angle AEC will be greater than angle D. We see this angle will be definitely greater than this D. Okay, and so in this equation where angle AEC stand, if we substitute by a lesser quantity angle D, here angle D is less than this angle AEC, and so here if we substitute angle AEC by angle D, the sum of angle B and angle D will be less than 180 degree. See, that means the sum of these two angles will be less than 180 degree. Hence we see when a circle is drawn through three vertices of a quadrilateral, if the fourth vertex is out of the circle, then angle at that vertex, that is angle D, with the opposite vertex together, their sum will be less than 180 degree. Now let us see the other case. When the fourth point is inside the circle, what will be the sum? Okay, let us check. Before discussing the other case, first of all write this question and draw this figure there and explain these things in your notebook. Okay, pause the video and write down. Now let us discuss the other case. See, that means when a circle is drawn through three vertices of a quadrilateral, at that time the third vertex or the fourth vertex is inside the circle. See, here a quadrilateral is there. When a circle is drawn through these three vertices, then the fourth has got inside the circle, and so let us name the quadrilateral by ABCD. See, ABCD is the quadrilateral. All the vertices ABC are on the circle while D is inside the circle. Okay, now we have to find out the speciality of the sum of the angle D and angle B. Okay, for this let us join, let us extend CD. Let us extend CD and it will meet at a point on the circle. Let us name it by E like that. When it is extended, it will meet at a point on the circle. We name it by E. Then let us join EE. Okay. Then let us write that much steps that we have done. Here we have extended CD and where it meet the circle is named as E and AE is joined. Okay. Let us write those things. Now see, ABCE, that quadrilateral is a cyclic quadrilateral, so all vertices are on that circle, and so ABCE is cyclic quadrilateral, it is cyclic. Therefore angle B plus angle E will be 180 degree. Let us write that one. Angle B plus angle E is equal to 180 degree. Now see the triangle ADC. Angle ADC is its exterior angle. See angle ADC, that one is an exterior angle. Now that exterior angle will be equal to these two remote interior angles. See the remote interior angle, when that two smaller angles added, their measure will be equal to this one. Okay, let us write that one. Angle ADC will be equal to the sum of the other two interior angles, mean it is angle E plus angle EAD. These two angles together gives this one. So we see angle ADC equal to angle E plus angle EAD, mean angle, these two angles are the components of angle ADC, mean angle ADC will be larger than each one of this. Okay, let us write angle ADC. Our consideration is on angle E, therefore angle ADC definitely will be greater than angle E. Now here in this equation, angle B, with this angle B, when angle E is added, it will be 180 degree, and instead of angle E, if we substitute it by a larger quantity angle ADC, that amount, that sum goes more than 180. Okay, here angle E is less, than angle ADC, and so instead of angle E, if we substitute it by angle ADC, their sum will be more than 180 degree. And so what we have got here is that when a circle is drawn through three vertices of a quadrilateral, if the fourth point is inside the circle, then the sum of angles at that vertex, that is angle ADC, with the opposite vertex gives a sum which is greater than 180 degree. Okay, in the first case we have found, okay, before that one you have to draw such a figure, then write all these notes there in your notebook. Here this one is a case 2, there the fourth vertex has come inside the circle. Write down, first draw such a figure and write down these things there in your notebook. After that let us explain. Pause the video and write down these things. Now we see when a circle is drawn through three vertices of a quadrilateral, we see if the fourth vertex is out of the circle, the angle at that vertex with the opposite vertex gives a sum which is less than 180 degree. When the fourth vertex is inside the circle, the sum of the angle at that vertex with the opposite vertex gives a sum which is greater than 180 degree. So we see if the sum is 180 degree, the fourth vertex is neither out of the circle nor inside the circle, it is on the circle. Let us write that one. See, if the sum of the angles at opposite vertices of a quadrilateral is 180 degree, when we draw a circle through three vertices of the quadrilateral, the fourth neither goes out of the circle nor come inside the circle, it will be on the circle. From this much discussion we have to conclude so. And so when opposite angles of a quadrilateral gives the sum 180 degree, if we try to draw a circle through three vertices of a quadrilateral, fourth also will be on that circle, mean that quadrilateral will be cyclic quadrilateral. Mean if opposite angles of a quadrilateral are supplementary, the quadrilateral is cyclic. That means we can draw a circle as passing through its all vertices. Okay, this one is the result we have got from this much discussion. You have to write these two things and at last this result in a box. Now let us have some problems solved. You know what is a trapezium and what is an isosceles trapezium. If a quadrilateral gets its one pair of opposite sides parallel, it is trapezium. If its other two non-parallel sides are equal, we call it isosceles trapezium. Here we have to prove an isosceles trapezium is cyclic. That means we can draw a circle as passing through its four vertices. If any quadrilateral is to be proved cyclic, we need not to draw a circle as passing through all its vertices. We need only to show its one pair of opposite angles gives a sum 180 degree. And so here also we are going to adopt that method. For this, let us first draw a rough figure of an isosceles trapezium. That in the figure it shows a rough figure of an isosceles trapezium. Let us name it as A, B, C, D. And so we have to prove here one pair of opposite angles gives sum 180 degree, mean we have to prove angle A plus angle C is equal to 180 degree. Anyway, we know angle B plus angle C is 180 degree as AB and CD are parallel line and BC is a line cutting that two parallel lines. So cointerior angles are supplementary, mean angle B plus angle C is equal to 180 degree. And so in our answer that can be the first line to be written, that is AB and CD are parallel, therefore angle B plus angle C is equal to 180 degree. Okay, and if we could prove angle A and angle B are equal, let us substitute angle B by angle A so that angle A plus angle C is equal to 180 degree. That means opposite angles gives a sum 180 degree, hence we will have done. Then our next aim is how angle A is equal to angle B. That we can prove very easily as we drop two perpendiculars from D and C to AB. We see there two right triangles. Okay, that two right triangles get same hypotenuse as they are equal sides of an isosceles trapezium. AD and BC are equal mean these two triangles get same hypotenuses, and their other two sides are also are equal as they are distance between two parallel lines. Therefore, one right triangle get its hypotenuse and one side same as that of the other triangle. Then these two triangles are congruent mean angle A is equal to angle B. And so, since ABCD is cyclic, that means AD and BC are equal mean ABCD is an isosceles trapezium mean angle A is equal to angle B. For any isosceles trapezium, its base angles will be equal. And so, here let us write, since ABCD is isosceles, angle A is equal to angle B. Now let us substitute angle B by angle A. Therefore, it will be angle A plus angle C is equal to 180 degree. That is, one pair of opposite angles of this quadrilateral gives a sum 180 degree mean that quadrilateral will be cyclic. If angles of a, since here angles are opposite angles are supplementary, this quadrilateral is cyclic quadrilateral mean an isosceles trapezium is cyclic. Hence we have done. Now the question from the page 57. Read the question. Here a cyclic quadrilateral is given and some angles on that figure are given. We need to determine all angles of the quadrilateral and the angle between the diagonals. For this, at first let us redraw the figure here. Okay. See, and angles given here 50, 30 and 45 are marked. Let us name the quadrilateral by A, B, C, D. See, it is a quadrilateral ABCD now. We need to determine angle A, angle B, angle C and angle D at first. See, here one angle is 30 degree mean it is the angle made by that arc AD at its alternate arc. In that way, angle ABD is also angle made by that arc ADB at its alternate arc. So that angle also will be 30 degree. See, that angle will be 30 degree. See, now angle B is 30 plus 45, that is 75 degree. Now to determine angle D. Angle B and angle D are opposite angles of a cyclic quadrilateral. We know their sum is 180 degree. Now one angle alone is 75, therefore the other will be 180 minus 75. Now we have determined angle D. Okay, now angle B and angle D are obtained. Let us write these much things there. At first, angle ACD is 30 degree, so that angle ABD also is 30 degree. Therefore, angle ABC will be 30 plus 45 is equal to 75 degree. We see their sum is 75 degree. Now angle D is 180. These two together gives 180. Therefore this one 75. Therefore this will be angle D will be 180 minus 75. That is 105. That means this total angle will be angle at the vertex D will be 105 degree. Now to determine angle C, we have to get this unknown part also. That part will be equal to this one, as they are angles made by the arc AB at its alternate arc. Now the angle at the vertex D is 105 and one part is 50 degrees. Therefore angle ADB, this unknown part will be 105 minus 50. Let us write here that one. Okay, this will be then 105 minus 50 will be 55 degree. Will be 55 degree. This angle will be 55 degree. Let us write. We see that angle is now 55 degree. Therefore this angle is also 55 degree. This angle also will be 55 degree. That is angle ACB is now 55 degree. ACB is now 55 degree. Therefore total angle at the vertex C, angle C is equal to 30 plus 55. That is 85 degree. This total angle is 85 degree. Like that, this one ABCD cyclic quadrilateral, this one 85. Therefore angle A is equal to 180 minus that 85. will be 95 degree. Now all angles of the quadrilateral ABCD is known. We have calculated all angles, and let us write all those angles together. It will be like that. Then angle A 95, angle B 75, angle C 85, and angle D, here you have to read it as angle D is 105 degree. Here I left and D there, you have to read here angle D is 105 degree. Okay, now consider the triangle, this smaller triangle. Here two angles are 30 degree and 50 degree, therefore this angle will be 180 minus the sum of these two angles, it is 80, therefore this will be 100, so that its opposite angle also will be 100. These two angles are linear pair, this one 100 means this will be 80, so that this one will be 80. Therefore all angles between the diagonals are determined, they are 100 degree and 80 degree. Let us write that one as the last step to this question. Angles between the diagonals are 100 degree and 80 degree. Hence we have done the first question in the page 57. Now let us go to another question. Now read the third question. Prove that parallelograms which are not rectangles are not cyclic. What do this question ask here? Parallelograms which are not rectangles are not cyclic. That is, among parallelograms only rectangles can be cyclic. In other words, if a parallelogram happen to be cyclic, it is possible only by a rectangle. For this, we will suppose a parallelogram is cyclic. At last, we will come to agree it is a rectangle. That is the way to prove this one. And so here a parallelogram is drawn. Let this be a parallelogram. Let us name it as A, B, C, D. A, B, C, D. See, A, B, C, D is a parallelogram. We suppose this parallelogram is cyclic. That means a circle can be drawn through all its vertices. And so we suppose at first ABCD is a parallelogram and it is cyclic. Now since ABCD is a parallelogram, its opposite angles are equal. For any parallelogram, its opposite angles are equal. Therefore angle A is equal to angle C. It is cyclic. ABCD is cyclic, mean its opposite angles gives the sum 180 degree, mean angle A plus angle C equal to 180 degree. Angle A equal to angle C and angle A plus angle C is equal to 180 degree. Two equal measures give 180 degree the sum. Therefore, each one of them will be half of 180, that is 90 degree. Angle A and angle C is 90 degree. Similarly, we can prove angle B equal to angle D is equal to 90 degree. Mean, we have supposed ABCD a parallelogram and it is cyclic. At last we come to agree its all angles are 90 degree, mean this parallelogram get its all angles 90 degree, mean it is a rectangle. Now if we take any parallelogram and think, suppose it is cyclic, at last we have to go through these steps and agree it is a rectangle at last. Therefore only rectangle can be cyclic among parallelogram. Hence we have done. Now let us do one more problem. See the figure, read the question. It is said ABC is a triangle. P, Q, R are points on the sides of the triangle. See triangle AQR, BPR, CPQ. Circumcircle of triangle AQR and triangle BPR are drawn. They meet at 2 points. Now the second point where they meet, just see the point. We have to prove when a circumcircle of triangle CPQ also is drawn, it has to pass through the point where the other two circles meet. We will prove this one not by drawing such a circle. We have to present the arguments why we tell the circumcircle of triangle CPQ also has to pass through the point where the other two circles meet. For this, let us first redraw triangle ABC. See, ABC is drawn. Let us name it as ABC. Now, 3 points on the sides of BC, CA and AB are marked. Any 3 points can be marked on the sides of the triangle. The points are marked there. Let us name it as PQR as given in the question. It is PQR. Now, on joining QR, we will get a triangle. When the circumcircle of that triangle AQR is drawn, we will get a circle as shown. Like that, on joining PR, we will get a triangle BPR. When the circumcircle of that triangle is drawn, we will get a circle as shown. We see that two circles meet at 2 points, one at R, the other a point here somewhere, we name it by O. And so, when we answer, let us write like this. Circumcircle of triangle AQR and triangle BPR meet at 2 points clearly, one at R, the other point let us name it by O. Let us write that much things. They meet at 2 points, one R, another O. This point is named as O. See, to determine, to ensure that when the circumcircle of triangle CPQ on joining PQ, joining P and Q, we will get a triangle CPQ. When the circumcircle of that one is drawn, that circle pass through O. We have to prove that one. For that, if we join OP and OQ, we will get a quadrilateral there. Joining OP and OQ, we will get a quadrilateral. If we prove angle POQ plus angle C, angle POQ plus angle C is 180 degree. If we could prove angle POQ plus angle C is equal to 180 degree, we tell that triangle is cyclic quadrilateral. Mean when a circle is drawn through CPQ, or that is a circumcircle is drawn through CPQ, it has to pass through O also. For this, we need only to prove angle POQ plus angle C is 180 degree. If opposite angles of a quadrilateral is supplementary, mean the quadrilateral is cyclic. And so, we have to prove angle POQ plus angle C gives a sum 180 degree. Okay, and so let us determine how much is angle POQ. Then let us add that measure with angle C so that we will get a sum 180 degree. And so that is the way that we have to adopt. And so let us first join OQ, OP and OR. We see the figure will be like that. Now let us determine angle QOR, angle POR, then let us determine at last angle POQ. And how much is angle QOR? Okay, CAQOR. It is a cyclic quadrilateral. This one is a cyclic quadrilateral. Therefore, angle QOR and angle A together will be 180 degree. Therefore, angle QOR will be 180 minus of angle A. This angle will be 180 minus of angle A. Like that, this angle, angle POR, this angle will be 180 minus angle B. See. Now these two angles are determined. Now the remaining angle POQ, total angle around a point is 360. Two angles are there here determined. Therefore angle POQ will be from 360. We have to subtract the sum of these two angles. Therefore angle POQ will be from 360. We have to subtract the sum of other two angles, that is there. Now see. In the bracket, two 180s together will be 360. On getting this minus, it will be minus 360, will be cancelled by this 360. Therefore, inside the bracket, a minus angle A minus angle B, on getting this angle, it will be plus angle A plus angle B. That is the measure of angle POQ. Therefore, angle POQ, there it is left, angle POQ equal to angle A plus angle B. That means this angle POQ will be the sum of these two angles. Therefore, angle POQ plus angle C will be angle A plus angle B plus angle C. This one alone, angle POQ alone is angle A plus angle B. Therefore, when this angle C is added, it will be angle A plus angle B plus angle C. Let us write that step. The sum of three interior angles of triangle will be 180 degree. What we have done now? We have proved. We want to prove angle POQ, or we expect to get angle POQ plus angle C is 180 degree, that we have obtained now. And so that means this one is a cyclic quadrilateral. That means when we draw a circle to pass through CPQ, that circle also will pass through the point O where the other two circles meet. That means all circle has to pass through a common point. Hence, we have done the proof to this question. Draw this figure and write down these much arguments in your notebook. Now, let us conclude the class. We have been doing questions in the page 57 and 58. Now, we have done some questions in that 2 pages. The remaining questions, question number 2, 4, 5, 6. Here I am setting aside that one as homework to be done yourself. Whatever doubt is there with you, contact me. Okay. Thanks.